This is a technical walkthrough of R5 of the Bloom system. So here we have the LED power supply. It's a 48 volt, 120 watt international power supply. And that is mounted with two pieces of dual lock 3M Velcro. We have the motor, which is a ClearPath VC model with a self-contained brushless included servo, set with USB to spin 888 RPM with an acceleration of 350 RPM per minute. We have the power supply they sell, the Technic IPC5. We have the board that I built, the screw terminals for the digital motor communication, for the LED, and for the user interface. On the other side of the board, we have the Arduino Metro Mini, an Adafruit product. We have our power resistor to reduce the current in LED, and we have our tried and true IRL Z34N N-channel MOSFET, and that's switching on the other side of the 48 volt 100 watt LED. The dip switches haven't been programmed for yet, but this is the behaviors we're going to be going for. The motor is attached with three little screws, 3 ring nuts on threaded studs that come through, and the Arduino is powered by regular USB wall wart that also has 2 AC outlets for the 2 power supplies. And then we have a short cord to plug in, and this can run at 220 if this is modified. So on the black power supply, you can unplug the AC plug from here, and then if you want to run this at 220, this black wire needs to be cut and the ends need to be taped. So if you need to run this at 220, you simply unplug that receptacle, clip the jumper, tape the ends, and then use an adapter for the plug. And the fabrication technique, we start with the Xylam brand pedestal, which already has 2 holes, and we need to drill either 3 or 4 more depending on the design. This video, we drill 3 more, shown here in the center, until using 1/4 inch flathead screws that are drilled 1/4 inch and then countersunk. So we have about 3/4 inch of 1/4-20 studs sticking through the bottom, held on with nylon lock nuts, both as spacers and to prevent them from backing out. These mate with the laser cut motor plate, this black acrylic motor plate. You then attach the hub to the motor. You clamp it on using an Allen wrench, using a parallel to ensure perfect orientation of the hub with relation to the motor. Then test the fit onto the threaded studs. Now we move on to mounting the 75 volt DC ClearPath motor power supply using a custom-made aluminum bracket. There's just 2 1/4-20 holes in a long piece of aluminum. The positions are marked with a Sharpie and then drilled and countersunk 1/4 inch. The countersinks have to be pretty deep unless you can find 3 1/4 inch screws. I had 3 inch screws, so I had to make the countersinks extra deep in order to reach. Once you have the hole drilled and the mess cleaned up, you simply put the power supply in between the screws, hold the bracket, and then alternate tightening the screws until the power supply is successfully mounted. Now we begin wiring up the ClearPath motor. I recommend doing this while the motor is outside of the chassis because the angles make it very difficult and very tight to fit in. The blue wire is the control wire, that gives digital signals to determine the speed, and the black wire is the power wire, which gives it its 75-volt DC that it uses as its power. You then, after positioning it over the nuts, you tighten each of the 3 nylon locking wing nuts until it's snug. Now we move on to the 48-volt DC power supply for the LED. You'll need a very short AC cable with ferrules on the ends, as well as a orange and black, about 12-inch DC cable to wire up the power supply. So first you clean all the surfaces with isopropyl alcohol to encourage the adhesion of the 3M dual lock Velcro. Then you peel off one side, you stick it on the power supply, peel off the other side, position it where you want it to be, give it a good squeeze, and then finish it off with a C-clamp to apply more pressure. You then have to wire the AC and DC sides according to the labels. All screw terminal connections are crimped with ferrules for repeatability, reliability, and safety. Here's the C-clamp tightening the VHB. I already went over the components of the board, so now I'll go into the actual installation instructions. The first step is optionally to zip tie the MOSFET to the power resistor to prevent it from getting damaged if somebody reaches their hand in there. After that, you obtain this short micro USB cable, and you plug it into the Arduino, and then you zip tie that to the actual acrylic board as strain relief to prevent damage to the actual Arduino. And that's happening now. You then position it and prepare it to be Velcroed to the inner ring using the 3M dual lock very high bond Velcro adhesive. So just like with the power supply, you peel it, you stick it, you give it a good squeeze, then you finish off the pressure with a C-clamp to ensure a strong adhesion. The first thing I'm wiring into the board here is the 48-volt power from the LED power supply into the control board. And I'm using a 2mm flathead screwdriver. And those just connect to their color-coded and labeled terminals using the same screwdriver. I'm then connecting the motor logic pins. 4 of them go directly into the board, and then 4 of them go into a bus bar. The black ground jumper connects the bus bar to the control board, and the bus bar also connects to the other 4 ground wires on the motor. Refer to the wiring diagram for more precise instructions. Then moving on to the user interface, the wires for the optional button and optional strobe rate control knob are connected to their appropriate terminals. Note that the ground terminal is interchangeable between the two, and it is possible to share one ground terminal with both functions. This is the temporary user interface board used for testing with the button and the knob, and here is the back with its labeled terminals. Wiring is now complete except for the LED wires, which are added last due to the height of the LED neck. Dressing of wires is done with patience and zip ties. All the zip ties we're using are a special type of zip tie with a hole for a screw near the latching end of the zip tie. This allows for easy and robust cord management as the cords can be attached to the pedestal with 3/4 inch number 8 Phillips flathead wood screws. Try to push the cords as deep into the corners as possible to encourage heat flow, airflow, and reduce the congestion of the small cabinet. This is the AC wire for the motor power supply being attached with a screw mount zip tie. The final component on the underside of the cabinet is the AC splitter combination USB power supply, which provides power to both power supplies as well as the logic power to the Arduino. The first step is to zip tie its cord to itself to reduce its size and give it a mounting point. Plug both power supplies into its AC outlets and the Arduino into its USB outlet. It can then be mounted to the pedestal using the same 3/4 inch screws. A sandwich of extra Velcro is used to keep the USB plug from interfering with the black motor plate, which it sits nearby. Lastly, a cable clamp or P-strap, a 1/4 inch cable clamp, is used to prevent tension on the AC cable from interfering with the longevity of the project. The Arduino is now being programmed with a USB extension with the code in the database, and now the motor is being programmed with its parameters with a configuration file in the database. The motor must be configured with a PC. The entire pedestal is currently resting on top of 3 rolls of tape to prevent the axle from pressing into the table. The 2 spinning platters are both made of acrylic and can be scratched easily. They are attached to the motor using 3 832 machine screws. The head type will depend on which bloom is being spun. Line up the holes and tighten the screws using an imperial Allen wrench. The bloom can then simply be press fit onto the ring. Never handle the bloom with your bare hands, as it is white and becomes dirty easily. We can now move on to mounting the LED. The wire must be pushed through the 1/2 inch aluminum tube fully, and then through the pipe nipple, which is then threaded into the tapped bottom end of the tube. The wire can then be pushed through the pedestal itself, and later through the washer and nut, so the wire is not in the way of anything when tightening begins. The LED puck is press fit onto the end of the neck and then set with a tiny metric Allen head set screw. The hole in the pedestal may need to be widened somewhat to accommodate the pipe nipple. It should be tight to prevent wiggling. The pedestal must now be flipped in order to allow for nut tightening and wire hookup. Take the nut and the washer, flip the pedestal, thread the wire through the nut and then through the washer and then the nut, and begin finger tightening. When it is finger tight, switch to an adjustable wrench. Then plug the wires into the appropriate screw terminals and tighten with a flathead screwdriver. The bloom should now be fully functional. Apply power and test behaviors, optionally using button and knob to test interactivity. Anything that isn't covered in this video is almost certainly covered in either the manual, the electrical diagram, or the CAD. Feel free to reach out to me directly at robb@robb.cc. Thanks for watching, and it's been incredible being a part of this project. Happy blooming.